right, guys, let's talk about confidence intervals. That sounds fun, doesn't it? Okay, so we're going to start with a point estimate. And that means we've got a single value estimate for some kind of population parameter. So this is sort of the idea that maybe what I'm working with isn't the population. Maybe I've got data that comes from a sample and I'm trying to figure out what it might indicate about a population. Okay, now the most unbiased point estimate of a population mean mu would be taking my sample mean. But we already decided the mean of one individual sample is not necessarily going to be the same thing as what the population mean is, right? Right? Okay, but if I know what the population mean is, I can apply it for the mean of a sampling distribution of sample means. That's what we just did in 5.4. So this is saying that if I have a sample mean, that could give me a point estimate or estimate what the population mean might be, okay? But I know it's not going to be 100% accurate. So here is, I don't know, you guys keeping up with Mark Zuckerberg testifying before the Senate? Okay, well, you are aware of what all is going on, right? Okay, anybody quit using Facebook because of your privacy? I don't know that the issue is they haven't done a good job of protecting people's privacy. And so they've had breaches where lots of data has gone to different firms. They've been complicit, I think he's acknowledged, in allowing Russians to post things that may or may not have influenced the outcome of the election. I mean, there's just a wide range of things that he's being investigated for. So in the spirit of this is now going on, and we have to all be aware of issues regarding social media, we've got a social networking website that allows its users to add friends, send messages, and update their personal profiles. Gee, that sounds like Facebook to me. So the following represents a random sample of the number of friends for 40 different users of the website. Okay, I don't know if anybody in here falls in this category. Do we have anybody who has over 1,000 friends? Always cracks me up when I see that. Yeah. Oh, you do? Okay. So do you have like a business or something where you use that to advertise, or you just like people and you just, okay, so you just do lots of friend requests and you accept the ones that come to you. All right. So yeah, I'm nowhere near that. Find a point estimate of the population mean mu. Now, what in the world do you think we could do with this? Okay, well, doing it by hand would not be much fun, agree? But if I wanted to put them all maybe in the calculator in L1, I could let the calculator add them up and divide by how many items I had, which in this case was 40, right? Because it was how many friends 40 different users had. And I come up with a mean or an average of 130.8. Now that's logical, right? I mean, I had the list of how many friends 40 different people had. If I average them up, that would give me an estimate for the population, okay? Now, do you think that would be completely accurate to say that the average number of friends for all the users of Facebook would be 130.8? Because I may have that oddball group in my sample, or now I didn't notice anybody with over, let's go back and take a peek. I don't see anybody who has over 1,000 friends, but if we had put her in our group, she would have skewed us a little bit, right? Yeah, okay. So it all depends on the group you have and how large your sample is. Things might get skewed, which by the way, because I had 40 in my sample, did that mean that the central limit theorem would apply? Yeah, it would. Now, here's the deal. I've come up with a point estimate of 130.8. It may or may not be the population mean. My hunch is it's probably not. But what I would be interested in is coming up with an interval that would give me some cushion, so to speak, that probably I'd have a shot at the real population mean being in that interval. You know what I'm saying? If I say it's exactly 130.8, I have no wiggle room. But if I expand it out a little bit and I say, well, I'm pretty sure it's between this and this, I've got a much better shot that my real population mean would be in there. So this is going to be the idea, is how do we figure out how to get this interval to estimate a population parameter? And that's going to be based on how confident do we want to be that the interval estimate would contain that population mean, okay? And so it sort of depends on what you're doing, how much wiggle room you feel like you need. So we're going to talk about something called level of confidence, and they usually use the lowercase c to represent that. And that would be the probability that the interval estimate I've come up with would contain that population parameter. Typically, we're talking about the mean here. So C, that confidence estimate, is going to be the area under the standard normal curve between our critical values. Notice they have a negative z sub c. That means that's a critical value, and a positive z sub c. If the only difference between how these two look is one is positive and one is negative, what does that tell you about those? We kind of did this before when we talked about if we were trying to find values where 90% of the data maybe was centered about the mean.
Aren't they the same, but one's a negative?
You got it. They're exactly the same number, except one is positive and one's negative. And these are talking about z-score values. So this is going to be when we use a mean of 0 and a standard deviation of 1. Okay? So if my confidence interval, say, was 90%, I want that blue area that's shaded to be 90%. How much does that leave me in the tails? 10% between the two tails, and because there's two tails, when I divide 10% by 2, you're right, I got 5% in the left tail and 5% in the right tail, because I know it all has to add up to be 100%, right? Okay. Now, if the level of confidence is 90%, that means we are 90% confident that the interval contains the population mean mu. And there's something about the way that's worded that I kind of think we're going to come back in a minute, and we're going to change this a little bit. In fact, I was thinking about this earlier. Has anybody else noticed, this just kind of jumped out at me recently, typically when the weatherman would do a forecast, don't they usually say, oh, on Tuesday we've got a 30% chance of rain, okay? And when you hear 30% chance of rain, what does that sound like to you? Yeah, I mean, that would mean there's a 30% chance that it might rain, but there's a 70% chance it won't rain. It's more likely it won't rain than it will. Well, they've kind of begun to change the way they say that, or at least some weathermen have, because now instead of saying there's 30% chance of rain on Tuesday, they typically say that there will be a 30% coverage of rain. Not that there's,
of the viewing area.
there you go. What they've really meant all along is that 30% of the viewing area will see rain, 70% won't. Not that there's a 30% chance somebody sees rain. It's that 30% of you would be likely to see rain, 70% of you won't. It could be. That may just be a new way of kind of covering your tail. I'm not sure. But that's kind of the same thing we're going to look at here in terms of semantics, the way that it's said, because we're going to see in a minute. It's not really that we're saying that when I get this interval, that there's a 90% chance or a 90% probability that my mean is actually between these two numbers. What we're going to end up saying is that if I take a lot of samples, then 90% of the samples will have the mean, okay? Now, That's kind of a 6 one way, half dozen the other, but there is a difference in what is being said. So let's go through this and we'll kind of see in a minute that they're going to modify the way this is worded in just a minute. All right, so for example, if we wanted that 90% confidence interval, that would mean I'm looking for the z-scores that would give me 0.05 for the area in this tail, in the left tail. And if I go look that up in the table, or if I did an inverse norm in the calculator and I put in an area of 0.05, I'm going to get negative 1.645. So I'd have between a negative 1.645 and a positive 1.645. That would be where that confidence interval would be for my z-scores. Does that sort of make sense? 90% of the area would be between those two values. Now, the difference between the point estimate and the actual population parameter is called our sampling error, okay? And when we're talking about the mean, the sampling error is the difference between that point estimate, which is the X bar, and the mean. So if we took the difference between those two, that's the sampling error. The problem is we don't normally know what the mean for the population is. That's what we're trying to estimate. But we will have X bar values, but we know they're different from sample to sample, right? Okay. So the margin of error will give us the greatest possible distance between the point estimate and the value of the parameter it's estimating, using whatever level of confidence they tell us they want us to construct this with. All right, so you don't have to decide what level of confidence you want to use. They're going to tell you what level of confidence, and then we'll be able to calculate how to figure out what that interval needs to be so that we meet all those guidelines. Now, this is the formula for E. This is in your formula sheet, chapter 6. This capital E stands for margin of error. And notice the formula is Z sub C. So if it said a 90% confidence interval, that means I'm going to use 1.645 because that's the Z-score that would go with that. And I multiply it times the standard error of the mean, which is what we just did back in 5.4. That would be the population standard deviation divided by the square root of n. And that's because we are going to have a sample size greater than or equal to 30 for this to work. So we're still applying the central limit theorem to this. And I know right now we're kind of going through some tedious formula looking stuff. We'll try to pull it all together in a second when we get to some example problems. All right. We can also, just like we kind of change standard deviation to be the standard error of the mean, you can also call this the maximum error of estimate or your error tolerance, okay? So a lot of times we'll hear, you know, we talked about this, I think earlier, if you were to get election time will be here before you know it, and all those ads will be back on TV. Big news today, Paul Ryan's not running again, so there's going to be all kinds, and this is just killing me in the stock market. I think I probably shared with you guys my stock market experience. But what we're going to start hearing is the results of whatever poll they have taken on some race, some election race, because we're going to, in fact, we're having runoffs, I guess, in May. And it will tell you that so-and-so has a lead of 55% to 45% with a margin of error of something, right? That's giving you that confidence level, that parameter of how accurate do they feel it is. You could do plus or minus that amount on either one of them and still be, and you would be covered, basically, is what it's saying, okay? Now, back to our social networking website. If we want to have a 95% confidence level to find the margin of error for the mean number of friends for all users of the website, and it says that the sample standard deviation is about 53, okay? So if we were to do that and we want to find the margin of error, what was the formula for margin of error? Do you remember?
Z sub C times standard deviation divided by this square root of mean.
All right, so E is equal to Z sub C times that population standard deviation divided by the square root of n, right?
I don't see that on the formula sheet.
Chapter 6.
It's chapter 6 right there.
Oh,
Okay, I know, just figuring out where these things are is sometimes half the battle. So we're in chapter 6. That's your formula for finding your margin of error. Now, since I want a 95% confidence level, let me just sketch this. We know the central limit theorem can apply because how many was in our sample? 40. But since we're looking for a z-score, because our confidence level, we use z-values, we're going to think about when the mean is 0, the standard deviation is 1, and we're going to want to have 95% of the data in between these two values. How much does that put in my tail? That didn't sound right. Sorry. 2.5 each, because I've got 5% that I've got to divide between these two tails. So this is going to be a 0.025, right? Whenever I take it from 2.5% and I make it into a decimal. Now, I can look it up in the chart if I want to do that, or let me remind you, you can do inverse norm. So if I did second bars and I go to inverse norm, I want to find what z-value gives me an area of 0.025 with a mean of 0 and a standard deviation of 1. And I've got negative 1.9, this would round to be 1.96, right? And when we're using the z-score, we're always going to use the positive value of it. So can I just use positive 1.96? Because what this tells me is this is going to be a negative 1.96 and this is going to be a positive 1.96. So far, so good?
I'm going to look at the second one.
Okay, question, Jennifer?
What numbers did you use when you did inverse norm?
What I did is I put in the area to the left in this tail.
Okay.
Since it was 0.95, that meant I had 1 minus 0.95 or 0.05 that had to be divided between the two tails. And if I take 0.05 divided by 2, I get 0.025.
Okay.
So
you have the 0.025 and then what?
And then a mean of 0 and a standard deviation of 1, and that'll give me the z-score.
Okay.
That will give me 95% of the data in between. Okay, sure. So here's what I need. I need to take that z-score, which is going to be a positive 1.96, and I've got to multiply it times, what am I going to use for that standard deviation? 53. And divide it by the square root of how many people were there in the list? Do you remember? 40. If you go back and look at the page before, we had 40 different items in the list. Okay, calculate that out and see what you get. What are you guys coming up with? All right, so if we were to round one place to the right of the decimal, would that be about 16.4? So here's what that means. I'm going to put 3 dots in a triangle, which means therefore. So since I have looked at this, and I'm trying to find, using a 95% confidence level, the margin of error for the mean number of friends, what this is saying is that you are 95% confident that the margin of error for the population mean is 16.4 friends. Okay? So I'm 95% confident that I should be able to use a margin of error of 16.4 friends on either side of what I came up with for that point estimate. And that would give me a good feel for where that population mean should be. Okay? So this is asking us to now take this information and construct a 95% confidence interval for the mean number of friends for all users of the website. Now, if you look at your formula sheet, here's how you construct a confidence interval. Once I've found that margin of error, all I have to do is subtract it from the point estimate to get the low end, add it to the point estimate to get the upper end. And that would be the interval that I'm going to think that the actual population mean is probably between, okay, with 95% confidence. So if I were to take that X bar value and subtract 16.4, then I think the mean would be between that and the X bar value plus 16.4. Now, what did we find for our X bar value? Do you remember? Oh, sorry. Do you guys remember what our X bar value was? I think it was 130.8, wasn't it? We didn't actually put all that data in the calculator and crunch the numbers. We took the PowerPoint's word for it. That was taking all 40 of those numbers and adding them up and dividing by 40. Gave us 130.8. So if I were to take 130.8 minus 16.4, 130.8 minus 16.4, I've got 114.4, which is less than or equal to the population mean, which would be less than or equal to, and if I add 16.4 to 130.8, that's going to give me what? 147.2? Is that right? Now, let me take you back here for a second and just show you this is what we did. There's our area in the tails. Came up with those Z values, which, by the way, you guys got your, well, I'll show you in just a second. If you've got your chart with your Z scores on it, there's a little help on there that you might not have noticed that you might be interested in. So I'll point that out to you in a minute. And then we were able to say, yes, the central limit theorem applies because we had a sample size that was greater than 30. Came up with 16.4 for that margin of error. And that told us that we had a 95% level of confidence that would be the margin of error, 16.4 friends. Just calculated this. This is explaining our symbols, which you don't have to worry about. We've already used these formulas before. And now we've got these endpoints. And that's exactly what we found, right? Now, I scrolled through there pretty quickly. Did you guys notice? Oh, hang on. Let's go to. Did you notice this part over here? Find the critical value Z sub C that corresponds to the given level of confidence. What does that say you can do? Or, oh my, does that sound like there could be a calculator shortcut for us? Let's get to it. Okay, so let me show you what you can do. By the way, somebody have one of those, here we go, I got it right here. Okay, let me just show you this real fast. Okay. Look down here at the bottom of this side of your chart. Do you see this? These are commonly used confidence levels. Okay. Now, they could ask you for a different one, and I would have to go and look for example, this is saying we want an area of 0.99. Okay. So I want 99% of the area to be centered around the mean. This is going to be the z-score that goes with that. Now, when I'm looking it up in the table, remember, it's got to go all the way out into the tail, right? So if I were to look this up, would I actually look for 0.99 in the area? How much is in the tail that's not included here? I'd have to add because there's 0.01 not included, so I'd have to add a 0.005, half of that to this. And so I'm actually looking for the area that would be 0.995 if I'm looking for it in the table. That's kind of tricky. You got to remember to make the adjustment. So if it's a commonly used level of confidence, this is the fast way to get it. We just did 95%, and it was 1.96. We could have gotten it right here. We didn't have to make the adjustment and look it up that way, but we can, okay? So I just wanted to point that out, that you see that there. But here's the cool thing you can also do. Let's say we wanted to get this interval, okay? Let's go to stat, and I don't think we've been here before. Let's go over to tests. So you might want to jot this down so you'll remember where we're finding this. And what we want to run is called a z-interval test. Anytime I'm looking for a confidence interval, I'm going to do a z-interval test. So I'm going to choose number 7. Now, you know how on the first page we had all the data for those 40 Facebook users? If we click data, that's going to mean I've put all those numbers in my L1. It's going to do all the crunching for me, okay? In this case, we might instead go over here to stats, and if we are using information that we calculated or being given, we could enter it this way. Now, this is asking for what the standard deviation is. What did they tell us in this problem?
How did you get it into the question? Mine's still question stats.
Did you arrow down? Try this.
I don't arrow down.
Okay. So what would we put in for the standard deviation? 53, because that's what they told us what to use for that standard deviation. What did we have for our X bar? This was what we calculated initially for the mean. 130.8, right? Okay, let me come look at where you are in just a second. And then how many items were in that list of Facebook users? 40, okay? Now, if we put all those in L1, we could just do data and it would crunch it for us. What confidence level do we want to use? 95%, right? So you would type in 0.95, and now when you hit calculate, oh my gosh, look at that. Is that the interval we just found? 114.4 to 147.2. That's pretty awesome. Okay, so let's see what yours has. If you go, okay, so because you're at data, so you go over to stats, and you enter, and then come down. I'll let you put that in, okay? Did that make sense? Look how it changes if we want to change the confidence interval. Now, that was a 95% confidence interval. It gave us the 114 point something to 140 something. Okay. 95% confident. Does that sound like I want to be pretty sure? So if I want to be pretty sure, does that mean I probably am making the interval bigger to make sure I've got the real thing in there? If I'm willing to work with a smaller margin of confidence, like maybe only 80%, what do you think that's going to do to my interval? Is it going to make it spread out further, or is it going to make it come in tighter? There you go. Let's watch. So let's keep the same data. But the only thing I'm going to change is going to be that confidence level. And let's say we'd be fine with an 80% confidence level, okay? Look how it changed. So instead of going all the way down to 114, it's only going down to 120. And then it doesn't go all the way up to 140, whatever, 147.2. It's just going to go to 141.5. So it closes in a little bit if I lower the level of confidence. It gives me a tighter interval. But if I want to have a higher level of confidence, it's going to spread it out. And so if you go where in the calculator, it'll do all this automatically for you. It's a Z interval. So you go to stat, tests, and then choose Z interval. Kind of cool, right?
Very.
Very, I know. It is so nice to have these little shortcuts. But it wasn't that it was that difficult to do it by hand. You can definitely do it by hand. So, this is what it would look like. Now, this says with 95% confidence, we can say that the population mean number of friends is between 114.4 and 147.2, okay? Here's another one. A college admissions director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9 years, and from past studies, the standard deviation is known to be 1.5 years, and the population is normally distributed. Is it important that it tells me that? Why? Because there's only 20 students. It didn't have a n value greater than 30. So let's get a 90% confidence interval of the population mean age. Now, if I were taking a vote, how many of you say, I'm a paper pencil person, I'm going to use my formulas and calculate the margin of error and build all this by hand? How many of you say, I think I want to do a Z interval? Oh, I thought I'd see those hands. Okay, so here's what we're going to want to do. We're going to go to stat, and I'm going to leave this up so you actually, do we have this? I might be able to switch over here. Yes, okay, so let me switch back over so we can see it on that screen and see the calculator at the same time. Okay, so if I go back to stat and go to tests and I choose Z interval, all right, I'm going to use stats because I don't have a list of values here. What would I put in for my standard deviation? 1.5, because that's what it tells me from past years. That's what it was known to be. What is my X bar going to be? 22.9. What is my N? 20. And what do I want to use for a confidence level? So 0.9. When I calculate, ta-da, what do we get? We round one place to the right. So it'd be 22.3 up to 23 point. I'm going one place to the right, that'd become 23.5. Okay? Everybody get that?
Can you go back?
That's okay. Can I do what? Okay.
And so when it asks this question, that's basically all we're doing.
When it's asking for a confidence interval, if you know how to do it this way, that's all you have to do. The 22.9 was the mean that they gave us, okay, for our sample.
So
Yes.
What's the answer?
Okay, so the answer is actually what shows up in the parentheses when you looked at your calculator. You should have seen rounded one place to the right. It would be 22.3, comma, and then after that you would see 23.5 if you round one place to the right. So our interval would be between 22.3 and 23.5, okay?
So on the computer, we'll make a quick little less than sign.
I think what the computer is probably going to ask, I mean, it's possible they could set it up this way with a box on each side. They may also want you to put a parentheses, type the lower boundary with a comma, and then the upper boundary, kind of like it shows up in the calculator screen. So we'll double check that when you look at the homework, because this is what it looks like if you actually put it on a number line. Now, here's the part that to me, is where they kind of shift gears, where I was talking about the difference in what Weathermen say now. Because the population mean is a fixed number, isn't it true that it's either in the confidence interval or it's not? I mean, logically, there is no other option. Either it's in there or it's not. So this is where they say it's incorrect to say there's a 90% probability that the actual mean is in the interval. Okay, what we're not calculating the probability that the interval contains the population mean. Instead, this is the way they're phrasing it. If a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain mu. That sounds different to me from how they've been stating it, okay? And I think this is the correct way to interpret it. I'm not going to be super picky with you on how you write it, and I don't think you're going to get, I know sometimes they give those little nuanced questions in the computer where you're having to select what's the right, I don't think you're going to see anything for this, but I just want to mention it to you because if you take another statistics course, this may come into play as far as making sure you understand it's not actually calculating the probability that the actual population mean is in that interval. Is just saying if I took a bunch of samples, 90% of them would actually contain the population. Kind of the difference between there's a 30% chance of rain and there's a 30% coverage area of people who will see rain. They sound kind of the same on the surface if you're not careful and you're not thinking about it, but they're really saying different things, okay? Now, this is what it would look like graphically if all of those are the different intervals that you found from, say, 10 different samples. 9 out of those 10 would actually contain mu. But notice this guy right here, he doesn't. All right, so if you have a 90% confidence level, it means if I take 10 samples, 9 out of 10 would contain the actual population mean. Now, here's the very last thing. This formula is also on your sheet for chapter 6. How to calculate a sample size. If I have a particular confidence level that I need to be sure I meet, and I'm given a margin of error that I have to stay within, that's going to dictate how big my sample size needs to be in order to meet those conditions. And this is how you calculate what size sample you would need. So if you're the one doing the research and you've got those guidelines you have to stay within, this is going to tell you how many samples you've got to collect. So N will equal, do we know where to find this guy now? Yeah, if hopefully it's going to be one of these nice clean numbers that appears on our Z-chart sheet. We can get that Z value there. The sigma should be given to us, okay, from the population. And then here's the sneaky part. We have a formula to find the margin of error. But if you look at the formula, what's one of the things you would have to know in order to calculate the margin of error? You'd have to know N, how many are in the sample. We can't do that if what we're looking for is going to be N. So here's what you got to watch out for. When you read one of these problems, they're going to give you a number for the margin of error. You've got to watch to see what it is because you may not recognize it at first. And then that means you've got everything that you plug in here and you square that number and that'll tell you how many you need in your sample. If for some reason they don't tell you the population standard deviation, I could use S, which would be my sample standard deviation, as long as there were how many in my sample. There you go. Okay, so let's look at a quick example. We want to estimate the mean number of friends for all users of the website. So if I want to have a confidence level of 95%, how many users need to be in my sample? If I want to be 95% confident that the sample mean is within 7 friends of the population mean, and they do tell us that the sample standard deviation is about 53. So this did not say population, standard deviation, it said sample, but does it qualify for me to use it as the sigma? I mean, we actually did a minute ago, and this wasn't clarified then. The reason I get to use it is because fine is greater than 30 in my sample that I have. So here's what I would need. Let me go back and show you on this. Okay. Now, we had a formula that they gave us for estimating sample size, and that was N equals Z sub C times whatever that standard deviation was, and it was divided by what? E, the margin of error. Now let's see if we can identify all pieces from this. Do I know what Z sub C is? Because what's going to be my confidence level? 95%. Is that one of the values that is given to me here?
Yes.
So I'm going to use 1.96. Very good. So N is going to equal 1.96 times, what do I use for that standard deviation? 53. Now here's the issue. I did not see the words margin of error anywhere in this. Did they tell me what the margin of error is?
Yes.
What is it? Excellent. That is it. It has to be within 7 friends. That means my E is 7. And this, oh, actually, I didn't finish the formula. Remember, after I calculate that, it's got to be squared. Okay? So do a little number crunching for me. Tell me what you're going to get if you put that in the calculator and then square that value. Do we need a sample that's bigger than the one we had? We had 40. Yeah. Is it quite a bit bigger than the one we had?
Yes.
It is. How much? What number are you getting? 220, and then there's what after that? 0.23, something like that. Now, typically, that does not round up, but think about, this is asking us to find the minimum sample size. If I round down and I only get 220, have I met my 95% confidence? So what am I going to say I need in my sample size? Very good. So we need about 221, or you might even want to say at least, in the sample. Okay, as long as I've got 221, I'm going to meet that 95% confidence interval requirement. Okay, questions? I think we're going to move to chapter 7.